Obviously, right?
I had this kind of insurance for the DevOps engineers a Linux engineer themselves. And he ended up hiring a friend of mine. And I was like, no, what are you doing is not with me. He's a configuration manager. He's not a systems engineer at all, right? He told me that's what you wanted. I could give you him. Literally, yeah, me and my friend. No, it's just that was funny. They don't need it. It's fun. I love it. It's so rewarding. You know, people like helping them, and every once in a while you get to speak to someone, you know, not working right now, looking for step up, you know, just become afraid. It's not very often. It's definitely the most rewarding.
Hey, you hooked us up with Omar. That was a
Omar, he was one of those guys that I met, and I was like,
dude, you're gnarly.
Is so smart, right? But he was working in like a really specific kind of healthcare environment, and was working with a lot of web technologies, and people just wouldn't even interview him based on his resume. He has a bachelor's degree and a master's degree in computer science. He's from Mexico. He's so smart. His English is amazing. And he's always like, I'm so sorry, my English is bad. I'm like, your English is better than mine. Send him an Edcast, and I'm like, oh my God, we love him.
Yeah,
We're just like,
hey, man, bet you can make it.
he's like that. Really, and he's thriving.
Yeah, if you're in the neighborhood,
Yeah.
yeah, just set your meetings up for the for the first Thursday of the month or second, depending
So they
on.
want me to come to a meeting at 3 o'clock in Santa Monica, so I just arranged for the entire
Cool.
meetings in that area, and I was like, and this will be the last one.
Right? Anything I can help with?
No, it's good.
Yeah.
Yeah.
Okay.
Yeah. Well, hey, we need a little entertainment.
That's in cheese, really.
Why not?
Why not?
You're like,
Yeah.
okay. Nope. Got napkins? Sorry. Yeah, they're on order. I'll be here right now. Sorry. Yeah, but we'll order napkins. We got lots of napkins. We're done. Your party at UUASC?
Okay. Live stream's up. I'm going to use the pizza and the beer and the speaker. Good to go.
What's your name? Daniel.
Oh, hey, Ralph, how goes it?
Right.
Nice shirt. Where'd you get that at? Nice shirt. Where'd you get
Right.
that at? You go to UUAC meetup where the redhead guy was giving out their shirts. I think you could make it. Well, this is the Sam on Cloud. Yeah, that's they were doing issues. When they were in the bags. In the bags, Good. last into the queue. Yeah.
All companies not on it.
Yeah.
Somebody asked you?
Oh, yeah.
She's too small.
They do really cool stuff over there.
Yeah, we're at the reserve.
Yeah.
The Home Depot. Yeah, right across the street from the Home Depot.
Yeah, the
Yeah.
post office.
Yeah, yeah. We got three buildings. We might host a meetup. They hosted a meetup there last week for this .NET. So we could host meetups there. But I kind of hold this spot.
Yeah.
What is it? Yeah, it smells good. Oh, this is one more.
Yeah. Yeah.
Yeah, but he drink. All right, so you have to put on the watch the cats. Huh? Oh, are the ducks playing tonight too? Really?
The guy, the backup truck.
Oh, really?
Yeah.
Yeah.
Well, he was getting out, and then there was no guys. He was gone.
Oh, really? Wow. I like the Blackhawks jersey.
Yeah,
He's been out of cat. Somebody stole this.
They're gonna wear a Blackhawks jersey around here. You probably don't want to push them.
That's the middle one of the original.
So you do any embedded stuff these days?
Private headline.
Oh, really? Good. Might be work, but you're still.
Private.
Oh, person. Sorry to hear that.
Almost in between the park.
Oh, ooh. No. Sorry to hear.
Yeah, I was getting to a lot of it. So you have to make sure you're part of the program. You know that after 20 years, the interest and I know that those really get sold for other day. I know they don't.
For a company that I know the guy who scaled,
Yeah, because we want to do a talk. Whatever. I don't play for the Clippers. We want to do a presentation. now. Yeah.
Because
No, it's
now
about time. Did you see Michael's talk? Michael, you know, he did the talk. I think he took the check the video. Yeah. Yeah, if you want to do my follow-up, we're about good. When we get settled in,
Possibility is nothing.
Oh, no. That's terrible. And well, there's other devices are showing up too.
The bike or sooner than 2 years. Great parking. Right? Yeah, no. Kind of like sex. Really, yep. All right. It's not like ghetto. Next to the ghetto. LA. Here. Also right here.
All right, more hands. Heading now. We're here. Yeah, please stand by. I should have some slides or something, but I don't. Well, usually, yes, those speakers flying in San Francisco. No, the Joseph Jacks, the host of the Kubernetes, he's doing the presentation. The other guy, Patrick Riley, he canceled. Yes, Joseph is
Going on the freeway for another the 605, and then you're.
So that was the case for the speaker.
Yeah.
Yeah, I can't even ignore that. Does it just change? Is it the same date, same time?
Yeah, no, I put a note in the top. I did say it. But I was maybe I should have been more liberal. But I didn't want to see it.
I didn't notice that. Just that change.
I didn't want to scare people away. Actually, one of the better meetups I went to was the speaker get canceled, and we just kind of crowdsourced on the topic. It was some like this related stuff. We just on the whiteboard just threw out different concepts and filled in all the little puzzles. And yeah, so we went after an hour or so. It's like, hey, I guess we don't have to talk this. That's proper, you know, kind of deal. Yeah. So that's what I was actually the production of the major developments, and then within the cloud itself. Well, especially have you been to the LA DevOps meetups? You gotta go to those because they alternate. One month it'll just be round robin, whatever. And the next month, it's presentation. So, just chatting stuff works really well. And every time, you know, adopt this, every time that you get everybody has to. That's what we do. I don't do that here. It's kind of a more, hey, somebody's talking about stuff. And with this, you know, I like to have a lot of Q&A. a product railroad with the speaker, but it's not trying to build a community through that. But kind of with DevOps, it's a little, yeah. If you took the LA DevOps model, I think that would work, especially OCs, you're probably gonna be small. Huh? But how many, like, you got units down there, and you have 150, no, but, that's actually pretty good. For the UUASC, yeah, but we haven't done it yet, so it's a bigger crowd now.
Money, Jordan, over to Jordan.
Huh?
Money, Jordan. We got supplemental.
Yeah, that's the plan. I don't know what's happening with the other thing. No, the speaker dialed in as some service that's bringing in. Oh, really? Oh, because he's from down there, right? It's 949.
And I was like, and I did
I did.
Yeah, it's only 7 o'clock.
I didn't know, take the bus.
Oh, yeah.
Yes. The last time I was in the UUASC, there was like 60 of us.
Yeah.
And then, probably that statement is probably why there's not.
Yeah, now we're all
Twice
60.
as much apartment for twice as much money. And I'm like, welcome to LA. The weather sucks. This is the weather's gonna be busy. And it sucks. I'm like, it sucks.
A lot more technical meetup options now than there were 15 years ago in LA.
Yeah. Oh, man.
UUASC used to be the thing.
Right.
There's so many different specialization options now that you kind of got 100 different things to choose from.
Yeah.
That'd be like.
Well, like this is Kubernetes was going to be the day before. I'm like, look, dude, no. Push it out a day. Let's join forces.
It used to be that Unix was
Right.
specialization, now it's becoming so
Well,
commonplace. It's almost, it's kind of assumed.
Yeah.
Whatever you're building, it's going to be running.
Unix, for this, Unix is just, you got to have the tangent that just skims past Unix and.
San Francisco, I believe you. I mean, even 15 years ago.
I mean, it's like almost, I could almost host Windows talks now because there's open source.
I mean,
showing up
most
in
places nowadays, it used to be Unix was what the job was about, and now it's like, Unix is assumed that you're going to be doing that, that's the platform, but that's not the focus.
Yeah. Well, yeah, and OSs are becoming, it's past apps or storage.
Containerization stuff kind of distracts.
Yeah. Oh, no,
The OS
the image level. So Docker has created a very intuitive and easy to understand packaging format for containers that's actually built on some core Linux kernel primitives that I'll get into. But again, just to level set, virtual machines require the full boot of an operating system. So you have your hypervisor on your physical machine, and you have a bunch of different sort of carved up, idealized hardware, sort of isolated environments called VMs. But each one of these VMs requires an entire operating system, run. Sort of bound to like a monolithic code base, you can kind of isolate that out, run it in a container, and just swap that out, upgrade it, deploy it as an independent unit, and still kind of have your whole application, working without being tied to any like global parameter, I guess. But
is it physically part of your memory? It's allocated to that. And
correct.
No application can be used.
Correct. It's totally isolated. So there's a couple features in the Linux kernel, namespacing and C groups that give you that flexibility. And so Docker, for example, uses those Linux kernel features to basically carve out CPU, memory, disk resources for a specific container.
The operating system you're talking about is always going to be Linux or Unix, not Windows.
It could be any Linux operating system.
Linux operating.
Correct. Yeah. The funny thing is now we're seeing this sort of ubiquity of Linux containers that like Microsoft is sort of building like Windows Server support for Linux primitives, which is just, nobody would have sort of guessed that years ago. So, pretty amazing. So again, I think we kind of covered this. It gives you this very lightweight notion of a VM without a lot of the overhead. You have a much better packaging semantics around sort of this is the agreed upon format that I'm specifying to run the application and run the code, and you don't have all these different dependencies and configurations and DLLs that you have to kind of worry about. Going back to sort of how they're isolated, containers are very, very portable, and they don't have any of these external dependencies that you would sort of presuppose with virtual machines. And again, they provide isolation at different levels. That's provided by the kernel control plane. So I mentioned a little bit of this before, but Again, C groups is really just sort of the resource parameters around the container. So it'll specify and enforce, like, how much CPU, how much memory that you'll actually be allocated for a container. And namespaces give you namespacing. So in terms of kids and users and mounts in that kernel space, you actually have you have kind of the ability to change the process's view within the system as it relates to other processes. And again, it's got some pretty cool capabilities. One of the things I'll note about C groups and namespaces is these are two Linux kernel features that Google actually contributed to the Linux kernel in, I believe it was 2006. And prior to that, they were using chroots and a few other variants of containerization to actually run their applications in isolated environments, sort of virtualizing the Linux kernel. And so Google's been using containerization for about a decade now. They've basically been big stewards of C groups and namespaces since about 2006. The other sort of noteworthy thing about C groups and namespaces is, again, Docker is built on top of C groups and namespaces, as is sort of any other modern containerization technology. So, like, the Docker is sort of above and beyond anything else that you'll see out there in terms of a containerization format. But we're also hearing from companies like CoreOS building sort of a different take on containerization with Rocket. But again, Rocket's also based on these core features in the Linux kernel. So these are like the foundational components that people are sort of writing their own abstractions and image specifications on top of. Any questions so far? So again, everything runs in containers at Google from their Gmail application, which I'm sure a lot of us use, to maps to the search index, to their distributed file system, storage systems. Google has a cloud, which is the kind of a competitor to Amazon Web Services. It's called Google Compute Engine, and all of the forward-facing sort of services that you can consume on demand in that cloud are actually run in containers. So the VMs actually that Google serves up, which are like highly modified KVM hypervisor VMs, actually run in containers as well. So
Google servers, not the client.
Sorry.
Think about the servers, not the client.
No, so the actual VMs that are spun up run in containers that users are consuming. So so Google has a system across all of their data centers to sort of manage resource allocation, and they're servers, right? So they need a common sort of interface to basically manage all the resource placement and resource negotiation. So I think that's the primary reason why they run it in containers. I think the reason we haven't seen sort of containers as a service and sort of instances that you would spin up on GCE RVMs is just for the security issues. And so you have one of the big issues with containers is you have a shared kernel across the host, and you have these kernel keyring exploit issues that come about when you're not sort of isolating things in an entire operating system per isolation environment. So there's a lot of reasons why they still serve up VMs, and I think that's why we'll see VMs for quite some time. And of course, Google launches billions of containers every week. So why containers? Containers provide performance, so you can spin up an isolated environment for your code in a matter of milliseconds. So you don't need to actually load sometimes hundreds of megabytes worth of operating system overhead for every single VM. Gives you this repeatability. So because of this common image format that's emerging around Docker, developers now have sort of a same way to define the way their code is sort of deployed in these Docker files, these Docker images. It uses kind of a file system layering approach, and sort of eliminating this issue around it'll work on my machine, but when I put it into QA, or when I put it into prod, it's not going to run correctly, or it's going to have some bug that I can't properly look into because it's sort of the exact same code base. I don't know what's happening. And so it eliminates that sort of runs on my machine issue. Provides the isolation, provides the quality of service accounting. Portability, again, is a big one. People want to be able to have a common way of defining the way the code is isolated and actually run in different environments. Docker, again, is sort of the poster child for modern containerization. We've seen this huge rise in popularity and interest. Funnily enough, I didn't actually plot the similar growth here, but Kubernetes is very close to that, actually, within the first 10 months of its existence. So Docker is about 2 years old now. They just passed their 2-year anniversary as a project, and some pretty exciting things there. So, what is Docker? A lot of people are like, is it a company? Is it an open source container thing? Is it a foundation? Docker is sort of, again, using these Linux kernel features to provide an intuitive and accessible user interface for developers. It's not actually introducing any new containerization technology. So it's really just an API and an image format on top of C groups and namespaces. And through that very intuitive and accessible API, they've been able to actually dramatically influence the adoption of containerization technology and actually provide that common standardized packaging format that a lot of people are beginning to agree on, which is pretty interesting. There's obviously a huge ecosystem that's coming out of Docker in terms of a lot of companies that have ancillary projects and tools. We've seen companies build sort of platform as a service products on top of Docker. We've seen continuous integration, continuous delivery tools basically being built upon Docker. We've seen public cloud providers just fully embrace Docker as like the supported unit of work, and that's like they're just going to ship Docker containers sort of everywhere. And of course, it's also a company, right? So a lot of people think it's just this open source thing, and it's all nice and lovely, and free as in free beer, and it's all good and great. The reality is Docker Inc. owns, manages, runs the Docker project. So it's not Apache Docker, it's Docker Inc. Docker. And so Docker Inc. has raised a significant amount of money. They have a lot of funding, and they have quite a lot of momentum.
Acquired other companies.
They've acquired other companies. They've sort of gone out and said, we want recently we want to be more than just containerization. We want to be orchestration and management and scheduling and service discovery and all these other things. And so they actually, through the explosive growth of Docker, are trying to kind of go beyond that. And so that's kind of an interesting thing to look at. And obviously, it's this big phenomenon. But the key takeaway is that the world is finally sort of starting to adopt containers in a big way, in a meaningful way. And I think that's going to really change the way people write software and build applications and just actually innovate in a lot of different ways. So
what do you say, juggernaut?
Well, I mean, it's just like they're just big force, in the open source, kind of world, and it's one of the fastest growing open source projects out there. Probably, I wouldn't say that it's the fastest. Can't confidently say that, but open source juggernaut, I think, is the appropriate description. So now that we have containers, sort of one of the things that I hear in talking to companies and learning about what sort of people are actually having to run into and actually solve for is like the entire application stack. So all the way up through to layer 7, it's like they're trying to rethink the entire thing. So like, how do we isolate jobs or applications from one another now that they're running in this new sort of isolation context that is totally different than virtual machines and what we've done before with hardware virtualization, with its operating system virtualization. How do things actually run and get kicked off? Because that unit measure is very different than it was before. The interfaces, these semantics are very different. How does the job continue to run? Like the life cycle of the job. One of the biggest things here is just the time to live, or the life cycle of containers is very different from VMs. And you can have, because of the lightweight, portable speed in which you can deploy these things, people are deploying hundreds of containers in a matter of minutes, and they just maybe live for a few hours and then they die. So you just can't do that with virtual machines for a lot of applications. So having to rethink how the life cycle works. Discovery is having sort of, I think a lot of these things are sort of being more granular. These problems really aren't new, but discovery is sort of a tricky one, because there's these applications now that are fully built and designed in containers, and you have to actually really have smart ways of actually identifying different components through naming schemes or through linking or a lot of different things people do to sort of figure out like where a job is actually running in a cluster in a shared environment. Constituency, like obviously there's these big workflows and service tool chains. So if you have a multi-tier web service and you've got your web servers, say serving up some play framework, and you've got your Rabbit system and your messaging layer and your caching layer and your front-end load balancers. All these things are sort of packaged independently in containers. How do you sort of figure out independently which one of those is actually connected to a specific application? And you have to really sort of define things differently. Scaling things up and down, so sort of elastically growing the size of your environment based on the number of containers that's supporting it is another big challenge as well. So a lot of the methods that people use are changing there as well. And then from accessing a system or authorization or authentication, you have a lot of different things people are doing as well. And again, monitoring, you're actually doing monitoring at a different layer in the stack because of the Linux kernel playing such a big role here. And then of course health management. Is this service alive? Is it actually healthy to the definition that I have as healthy, and is it going to maintain that state? So a lot of these problems people have to really think through again, and that's really where Kubernetes comes in here. So Kubernetes sort of, you could say, ultimately ideally addresses all of these problems in a single system, but without sort of forcing a monolithic kitchen sink on the developer or the operator. One of the big things, and so since so many of you raised your hands around, I've heard of Kubernetes, I'll just assume you've sort of maybe perceived or heard different comments about it. One of the big misperceptions about Kubernetes, as following the prior slide, is that it just addresses all of these problems and you have to adopt everything. And if you don't, it just doesn't work for you. And so that's really not true. It's a very composable modular system, so you don't necessarily need to adopt the service discovery model in Kubernetes. You don't necessarily need to adopt the way services are categorized or sort of assigned between one another. You don't need to adopt the way scheduling happens within Kubernetes. A lot of these things are optional and sort of pluggable. And so Google put a lot of thought into the design that sort of caused Kubernetes to be a very extensible, flexible system. Because in the real world, people have different sort of preferences for a lot of these different issues. So Kubernetes is essentially a container orchestrator, manager, and it essentially takes all of the years of running containers at scale that Google has amassed and compresses them into a system that basically people can use today and actually gain value from. So Google has, again, not only sort of been the one organization to sort of thank for modern containerization because of C groups and namespaces, but they've also sort of been the one example of a company running containers at scale and actually building bespoke systems, if you will, for managing containers. And I'll get into that in a little bit, and also sort of the design decisions behind Kubernetes and sort of why they were made. Kubernetes can run in any environment. That's another big thing that I think a lot of people don't fully realize. The only dependency with Kubernetes is Linux, so you can run it in any Linux environment. It doesn't necessarily need to run in any particular cloud or any particular framework or a bare metal configuration. If you have a box and it's got Linux on it, you can run Kubernetes on that box. Kubernetes is fully written in Go. So Go is a programming language that Google developed and released a number of years ago. I think 7 or 8 years ago, if I'm not mistaken. And it takes a lot of the sort of things from, if you're familiar with Erlang, in terms of parallelizing a lot of the processes and the way you actually design a system, and has some really nice concurrency primitives. to actually modern development environments, and it's a garbage collected language. It's
Deployment's pretty easy, right?
Yeah, it's super easy language. I mean, if you know Java, you can pick up Go.
So maybe did I just get like one Go binary blob, right?
Right.
It's that's pretty cool.
Yeah, I mean, there's a lot of really cool things that just make Go very approachable, and it's a highly scalable and efficient language. Makes really smart use of memory. So again, a lot of these things come from Google. Yep.
Do you have to use Go to configure or extend it?
You do have to use Go if you want to actually add like additional components or sort of dive into the code base. Yeah, so it's basically 100% Go. Good question for this presentation though. So what I will say, hopefully my screen comes back. Not all the components have to be ready to go. So the company that I work for, Kismatic, we call ourselves a Kubernetes company. I won't give you guys a commercial on what we do, but we.
You can give us a commercial. You bought the beer and the pizza, so that's fair enough.
No, we basically built. So coming back to your question, we built a web UI for Kubernetes, and it's actually JavaScript in Angular. So it's not in Go, and it's built into the API server. So there's a master and a node model. In the master, you have all these things to basically call and orchestrate, Kubernetes, and there's like an API endpoint. There's a server that manages all these interactions, and our sort of native web UI for Kubernetes.
So it lives outside that and just uses the API.
Correct, yeah. And so you can just, basically the master IP, you point your browser to the master IP and just like /static/app, and you see the web UI. So you just pull down Kubernetes from head today. It's in 0.16, which is the latest version. And that's kind of the native way to kind of visualize the pods and resource utilization. You can see all the services and events and basically everything in the system, kind of visually introspect all that. So you don't necessarily need to write everything, but the core components, obviously, you do need to use Go to extend this. So where did Kubernetes come from as a system? Like, what are the origins and the inspirations behind the system? Like, this wasn't just dreamt up by some smart Google engineers, on a nice sort of, that the 10% time that Google gives their people to sort of do interesting projects. It wasn't like, some interesting guys that came up with that. This is something that had to be solved at scale, by out of necessity. So, and this is sort of some of the most interesting problems are solved out of necessity, and Google has been one of these companies that has just scaled for many years and had to really figure out how to efficiently manage the utilization of their hardware, the utilization of their data centers. So there's a system internally in Google called Borg, and Google just very recently started talking about it and coming kind of out of the covers, if you will, with it. And they actually released a paper on Borg that was publicized a couple of weeks ago.
Oh, really?
I would encourage you guys all to read it. It's very approachable. It's an awesome read. And so Borg is basically the system that's been powering and managing all of the global data centers, comprising of millions of servers. And I can say this since I'm not Google, they wouldn't really comment on these numbers, but these are the real numbers. Millions of servers across hundreds of data centers. Since about 2004, the system's been in production. So it's all in C++. It's millions of lines of code. It has extremely granular and specific features that only Google will ever need. And so a lot of people think, why didn't Google just open source the Borg thing? They wouldn't. They couldn't. Nobody would use the system. However, as we all know, at scale, we start to see very cool problems that are solved efficiently that you can actually bring to sort of any scale kind of environment. And that's where Kubernetes was actually modeled. So you can actually see sort of this is the high-level Borg architecture from the Borg paper, and there's a lot of similarities here. So a cell is you could sort of view that as essentially a data center, and so tens of thousands of machines. Each machine has a little daemon on it called a Borglet that is connected and communicates to the Borg master, of which again very replicated and highly available across a cell. You know, there's a persistent store for managing the metadata in the environment, which is based on Paxos. Again, this distributed consensus and locking algorithm. There's a system internally at Google that is this system called Chubby, and that's what the persistent store is there. There's a scheduler that manages the execution and the placement of the jobs on the physical machines. So these are the physical machines. And there's a few ways of interfacing with the system. There's a nice web UI with very rich, sort of expansive view. This is one thing that I'd really like to look at. We've never seen any screenshots of the web UI for Borg, which is fascinating. I'd love to somehow get my eyes on that. There's a command line, and then there's a Borg config files that you just use, which actually has its own DSL. So Borg, I think it's called Borg descriptor language, DDL or something like this. But it's basically a DSL that Borg implemented to allow the Google site reliability engineers, the operations guys, to interface with the system. And obviously, any new engineer at Google who wants, compute resources, basically is introduced to Borg, and sort of when they leave Google, I guess they cry because there's nothing else out there that they can really use at this scale.
And and until last week, they couldn't talk about it.
And until a few weeks, they couldn't talk about it. So again, in summary, in summary, millions of servers across the globe.
The interesting line was below that, 50,000 instances
this is the thing that I didn't talk about, yes.
per SRE.
Yeah.
What's an SRE? Is that some kind of Borg machine?
Very good question. So these are literally brilliant genius, generalist people that are like jack of all trades. They can sort of debug anything under the sun.
But they're people.
They are people. And they're called site reliability engineers, or SREs, and they're essentially like the ops guys that get paged when shit hits the fan. Like when when the system implodes, these guys get called and they get summoned to fix stuff within they have a 2-minute SLA or something. They have to fix the broken stuff. And I'm not talking about going in and swapping out a disk. It's more systemic issues.
I worked for a Unix Linux consulting firm, and during their recruiting stuff, one of the kind of stock questions was, well, how many systems can you manage? So this 50K, that's getting up there.
Yeah, it's up there. I think some of the largest scale internet companies come close. I think Google is probably the highest there for roughly per SRE, a 50,000 machine. 1 to 50,000 machine ratio is extremely high, and it's literally a small number of SREs that manage the entire fleet of servers across all of Google.
How many platforms do you think are involved in this 50,000?
Well, Google claims to have standardized on Ubuntu.
Or even application platforms, right?
Like
a lot of the servers within that 50,000 chunk are be virtually identical in functionality, maybe different.
Right? Are they all search? How
good
many are
question.
file system?
This is literally everything. So
So
any sort of independent application you can think of that Google serves up, from Google Calendar to YouTube to the search index to maps to random self-driving car services that they're pushing out. All these things are technically called and termed applications in this paper. So this is literally anything that runs in a Google data center is deployed in this model, and I would imagine that they have thousands of applications with this. I took this from the paper. I didn't make this up. So this is the stuff.
right, because if they're going to build it that big, they want to push everything onto it.
Right, they want to standardize on the isolation model, which is C groups and namespaces. They want to standardize on a lot of things.
What is Meso?
Mesos. Very good question. So at Kismatic, we all happen to be ex-Mesosphere guys. So
Oh,
a
really?
little bit of insight there. So Mesos, Apache Mesos is a top-level project. It's actually a project that was implemented at UC Berkeley a number of years ago, and it was Ben Hyman's PhD CS thesis that he wrote. Again, it's sort of a third-party, reference implementation of what Google was doing with Borg. The Borg paper was not out 5 or 6 years ago when this system was implemented, and so some of the Google interns actually spent some time with Ben. So Mesos, as it compares to Kubernetes, isn't really a direct comparison. Kubernetes is more of a higher level orchestrator, and Mesos is like a low level scheduler that basically takes sort of jobs and executes them on a shared environment. You could take one sort of component of Borg, this scheduler right here, and say that's essentially what what Mesos is based on. With Mesos, you actually have to have higher level things built on top of it to really make it useful for developers. So you actually implement your own schedulers, and there's a paper called the Omega paper, which is a system that is actually layering on top of Borg. It's not replacing Borg entirely, but Omega actually outlines the differences between the Mesos scheduler, which is a two-level scheduling system, as it compares to the Borg scheduler, which is a monolithic scheduler, and the Omega scheduler, which is a more advanced scheduler that does a lot of cool things and it's much more efficient at like packing jobs. Does that answer the question?
We brought up comparison with Elastic Beanstalk.
Elastic Beanstalk. Wow, I haven't heard this one. So as
Amazon's container.
Yes.
Yeah, I mean, as it compares to Kubernetes, is that sort of your question?
Yeah, I don't know.
Yeah, I mean, Elastic Beanstalk, I'm not really that familiar with it. I've heard some things.
Promise a service where
Yeah, there aren't that many. So
only
yeah.
you can run like one application per container.
Yeah, it sounds like a pretty basic PaaS for EC2, and has some of the similarities to like a Cloud Foundry or an OpenShift type system, but like a watered down version, I guess.
Yes,
Not as much.
since we're starting to go out in the woods here,
That's fine.
I heard first about Mesos. There's this software engineering podcast, and I don't remember who they were talking to, but a guy who did a lot of the original Zen development, and he was talking about, I guess, microservices, right? So there's different hypervisors where basically you're gonna wrap the hypervisor around a specific job, run it, kill it.
Right.
So does Mesos use other types of hypervisors? I mean, one that I hear about is like ZeroVM,
Sure.
and which I guess is really designed for running, like say you would run it on a storage server head, so that it could be processing closer to the data.
Yeah.
But yet it would have more controls than say a KVM or something like that, and not consume extra resources or CPU cycle, something like that.
So your question was, I think it might have been.
But does Mesos use different hypervisors, and also with Kubernetes as well? What kind of hypervisors can it use, or schemes?
It's just Linux dependent. So again, you can run both Kubernetes and Mesos independently on any hypervisor.
Mm-hmm.
You can run them on any bare metal environment, or you can run them on any public cloud instance VM that supports a Linux base image. So again, it's pretty agnostic to platforms because the only dependency is a Linux environment. About I think Rackspace bought ZeroVM. If I'm not mistaken. I'm not sure what they're doing with it now.
Well, I think they're using it specifically for kind of storage.
Okay.
You know, to put the processing near the storage as opposed to bringing the storage into the compute area.
I see.
But in order to do that, you may have more restricted constraints because that same host may be handling storage functions as well. So you want to make sure that the VM or whatever, the guest is really ratcheted down.
Sure.
Can't consume too much memory or
So
what
I
have
could
you.
do a whole talk kind of on Kubernetes and Mesos and where those things diverge and where there's overlap and like.
Well, that'll be for the second Kubernetes-LA.
I think the big things are, of course there is a little bit of overlap between both systems, but Mesos does something very specific, which is basically implements this algorithm called dominant resource fairness. There's a paper on DRF, and this is a paper, by the way, that was actually authored by the same guys that wrote Spark at UC Berkeley, the Apache Spark project. So Spark was the first sample app written on top of Mesos. A fair amount of people know that, but I'm often surprised so many people don't realize that Mesos at UC Berkeley in the AMP lab was the first open source thing that they did in their badass stack, and Spark was the second system, and a lot of folks, if you want to
Or the killer app.
the killer, or I guess one of the frameworks right, that run on Mesos. But Mesos does something very specific. Kubernetes is aiming to also address highly scalable scheduling facilities, but today the scheduling in Kubernetes is very basic, so it's just round-robin scheduling. It doesn't have anything really intelligent around like a DRF implementation in Mesos. So if you're interested in DRF, you can read the paper. So this is, as of today, this is a little snapshot I took. It just as a sort of a snapshot of the momentum that Kubernetes is seeing, which is far above and beyond any other open source cluster manager for containers in existence, of which there are many. There's 11 months in, right? This project was open sourced in June of last year. 345 contributors. Last Monday there was 10,000 commits. Now there's over 11,000 commits to the thing. Quite a large number of issues that people are hacking away on. A lot of pull requests. So very vibrant, active project. And Google engineers really only comprise of about 60 of that number. So it's actually a pretty diverse number of companies that are contributing to the project, and it's pretty exciting to see all the velocity around it. Yeah.
You mentioned public cloud, so I want to introduce another again.
Sure.
How would Kubernetes fit in, and would it make sense to try to fit it into an Amazon environment, and what would you gain?
Great question. And we're actively working on that. So I think one of the cool things about Kubernetes is, again, it doesn't matter where you run it. You can still receive the same benefits. So on EC2, which is the Elastic Compute service from Amazon Web Services, where you just spin up VMs on demand, you have all these nice flavors of machine sizes and platforms that you can choose, and distros. As long as the instances that you run on are Linux environments, you can deploy Kubernetes on those instances and still sort of see all these benefits of containerization, one, and secondly, of deploying applications that are containerized in sort of logical groupings. And so, sort of microservice architectures, if you will. Not really packaged. So I'll get into the details around sort of what I mean by application grouping. Yep.
So on the Google Cloud, are they offering Kubernetes sort of ready to go, available directly? And you can
they are, yeah. So the Google guys.
Amazon, you've got to put VMs running Kubernetes. You sort of have to provide the.
Sure. You have to configure Kubernetes on EC2 instances to set it up. On Google, they actually have a container service that's analogous to the Elastic Container Service from Amazon. So there's two container as a service offerings from both Google and Amazon. One is called ECS, which is Amazon's. Both of them are based on Docker, by the way. And the Google one is called Google Container Engine, or GKE, a nod to Kubernetes. And what GKE does is actually makes full use of Kubernetes underneath. So Kubernetes is actually running in production on thousands of servers, and people are using it every day. And that's actually where they're battle testing and basically pushing the code out to a lot of people to test. As far as I think it's a couple of incremental releases. Not quite bleeding edge, but Kubernetes is actually there more turnkey on Google's cloud than GKE, because obviously Google created the project. But we're working on making Kubernetes more of a native kind of experience on Amazon's cloud on their ECS service. So you'll see some cool stuff there.
So it's a little more mature at the moment. But it's available. You can directly use Kubernetes.
Right.
Or put it this way, of the Kubernetes developers, where are they deploying most of their instances?
Yeah, so the customers that we're seeing,
yeah.
And again, that we know of, I don't believe we're talking to all of them. There's a lot of people playing with this. They deploy, I think, a very wide range of environments. A lot of customers deploy it on their private environments on bare metal. A lot of them deploy it on Amazon EC2. Some of them deploy it on Rackspace. Some deploy it on Colos.
OpenStack?
It's all over. So there are a few ways to run Kubernetes on OpenStack.
Yeah.
And we haven't seen anyone run sort of production services on OpenStack, but there's a lot of POCs and things happening in that area.
Or CloudStack, or any of those kind of
Right.
private cloud.
Right. Yeah, there's actually a lot of different open source projects that have been created to sort of bootstrap, Kubernetes on Cloud Stack VMs or on Nova VMs and OpenStack and these other environments. So I guess I'll kind of go through the design principles here, and then we can kind of get into what Kubernetes actually does and how it works. So Kubernetes design principles are first and foremost declarative. So one of the really cool things that I did just before I got on the plane in San Francisco 4 hours ago, so my flight was really late, but I used this service called Magic. This is like a really big pitch for them, but it's an awesome service. Fully declarative, right? I said, I need to get pizza and beer at this address, Q. Magic service, like, again, this is declarative. I didn't give them like all these explicit instructions, like, you need to do this, go to this specific pizza location, and then like order these specific items. I was just like, pizza, 30 people, beer, done.
Pizza, beer, these coordinates, this time.
They have my credit card file. So they call, I give them Jordan's number. They call. This is a declarative interface, right? I got a text back from this person. They're like, done.
Yeah.
It's all.
Yeah, and I can tell you
that was cool. And actually, we're kind of worked out. They didn't bring napkins.
And it worked, and we can drink to that.
And so declarative versus imperative. That's the really cool thing about Kubernetes. It provides an interface that gives you just a really simple way to, arbitrarily execute commands that, so sort of you need this set of containers running and with this specific service or these bits, and you need 10 of them running. And Kubernetes will make sure that 10 are always running. So it's a long-running service. If you have a couple of outages and there's this closed loop iteration around that desired state, Kubernetes will spin up 2 more instances to get it back to 10. And so that's the declarative versus imperative.
Yeah, getting into the declarative versus imperatives. Some of us may have or declarative, I guess, or versus like a procedural thing, right? Procedural is like what we're kind of used to. Well, no, Puppet is a declarative language. So the Puppet DSL is declarative, and that's a lot of people got hung up on that. It's not a procedural scripting language. You can't, there's not necessarily if statements, for loops, all that kind of stuff. You've got to describe the environment.
Right.
Chef.
All stack is small.
Yeah, but I think Chef you could break out more and make raw Ruby calls or something like that.
But this is at a much higher level. So moving away from config.
But still, people are going to have challenges. I think some people will have challenges of getting into a declarative mindset.
Yeah, and you do give up a little bit of flexibility at such a high level of abstraction away from like the specific things that you want to do and you debug and like what about this specific service that got lost and if it changed, what happened? Because these things are constantly being moved around.
Yeah.
So control loops give you this way to enforce the desired state or the declared state. Simple versus complex. I mean, I think this is just Unix philosophy. Like, there's multiple components in Kubernetes. Each one does a specific thing and it does really well. It's a componentized modular system, so you can swap these things out. I'll get into what those components actually are. Modularity, again, I just mentioned that. Requiring apps to change is a big non-starter for a lot of people. So again, if it runs in a container, it runs in Kubernetes. You can run it in a Docker image. It will run in Kubernetes. So this is the core substrate of the system. There's actually support. We just wrote a blog post about this. There's support for Rocket now as a first-class citizen containerization format in Kubernetes. It's not fully baked. There's a couple of issues still outstanding, but people can actually start to use other containerization models other than Docker now in Kubernetes, which is cool. Yeah.
If I recall, Rocket is sort of CoreOS's Docker.
Yeah, I mean, it's an alternative to Docker. So CoreOS is a company that has a minimalist Linux distribution that's basically a stripped down kernel. Yeah, so it has a lot of interesting security features. CoreOS wrote something called the application containerization spec, and they implemented Rocket against that spec, and that's basically something that is now sort of actually it took a little sort of a peek into the roadmap that Docker had around security and certain features and implemented them before Docker was able to sort of get to. So long, as you can imagine, it's a long list of things that Docker's worked. So yeah, kind of interesting. But I think the cool thing about that is it's just giving people choice. You know, as long as there's sort of a competitive, healthy competitive ecosystem, it's just going to push all this stuff forward a lot more quickly.
You're talking about the Kubernetes.
Yeah, I mean, there's support. There's sort of base primitives there today, but it's not fully baked. I'd say give it. Well, Docker was the core system that was built in Kubernetes in the beginning, so this native support for Docker. So legacy applications that can run in any Linux environment. It's network centric, so it gives you this ability to assign for the unit of scheduling work that I'll get into. You have a unique IP for each one of these things, and you know it's actually IPv6 compatible. So there's a lot of really cool things that you can do with Kubernetes. I don't know how many people are using the IPv6 support yet, but
well, because getting the IPv6 right, Google's been running v6 internally for a long time, and they couldn't scale to the 50,000 whatever instances per SRE type stuff without using v6.
But these aren't just instances. I mean, within each one of these instances,
you
probably got thousands of
and each service
endpoints.
Yeah, and each one needs its own address.
Each one needs its own address.
So v4 ain't gonna make it.
V4 ain't gonna make it. No grouping. So you know we don't have this idea of like hard coding partitions of services. Everything is extremely isolated, and because of that, you know you need a very rich sort of metadata prescription around these objects. So Kubernetes has this notion of a label and a labeling system, which is essentially any arbitrary key value pair that you want to write on an object, and you can actually query that. So I'll get into that in a bit. Bulk versus handcrafted. I think this goes just back to the cattle versus pets. People trying to treat their servers as disposable things. You know, if your cow is straying off in the wrong direction, it just constantly does that. Just shoot it and keep going with all the other cows, I guess. And finally, standard REST JSON out of the box, and open APIs pretty much everywhere. So here are the primary concepts. You can go into this, and I'll try and go as deep as I can here and answer any questions. Fortunately, I won't do a demo, but we'll go over all these components. So obviously, we have the container, which is the Docker image, and that's again kind of the core sort of unit of work across Kubernetes. A pod is this idea of a single container image or multiple container images logically grouped. So you could have one pod running some code, and then running some caching, and running some web server, all kind of grouped together. Or you could just have like your app server running in a pod. It depends on what you want to do. And the best practice is one container per pod. That's kind of the ideal setup. A controller or a replication controller is the piece of Kubernetes that basically enforces this desired state. So when you say Kubernetes, I need these pods to have five instances. This controller will always make sure that there are 5 running at any given time. So if one dies, it'll recognize that through this looping mechanism and spin up another one to make sure that 5 are there.
You said 5 instances.
5 pods. A service. This is one that kind of irks me a little bit. There's a little bit of a terminology sort of expansiveness to this word. It means a lot of things, but it's basically TCP UDP routing of traffic, and so it's basically a proxy that you can point to that directs traffic to a collection of pods, so many pods, and that gives you a lot of flexibility around around load balancing traffic.
So a service is kind of the edge at the edge of the Kubernetes thing to get that particular service.
Point, yeah.
You hit that one point, and it can hit multiple pods or whatever.
Yep. And you can have, you can have a large number of services in a Kubernetes cluster that comprise of a number of pods. Labels give you, again, this arbitrary key value metadata that you can assign to any object within Kubernetes, but specifically to pods. So you could say, hey, I want to gradually roll out some services and name them, Django slash Joe v1.2.
Right.
And the next one would be Django slash Joe v1.4. And you want to sort of gradually compare the user experience based on those two things. So it's extremely flexible. You can do tons of different things with it. You can do rolling deploys, canary deploys. You can granularly define all of your different microservices and the versions that comprise them. And it's an extremely powerful primitive in Kubernetes.
Are there standard labels, or are there developing standards of labels?
It's all up to
whatever you want,
to the developer or the operator. There's a sort of a JSON format that I'll show that kind of describes that.
Including the discovery processes.
Right. So you can do service discovery. You can do a bunch of different things with labels. And selectors are, again, sort of tied to labels, where basically a query in the system where you basically say, give me all the pods where you have this specific label.
Right.
And you can very quickly find things and filter through your services that way. So this is going to be really tricky, but it's kind of a master-slave, master-node architecture. So the master contains, I'll try and describe all this. The master contains the scheduling components of that round-robin scheduler about, once I'm told to run a container or sets of containers, Kubernetes automatically figures out, based on resource availability, where to run that. There's a REST interface for the replication controller, the pod, the services. You have authentication authorization of that through something called kubectl or kubectl, which you communicate to basically sort of spawn anything in the system. You have a distributed storage system that maintains and persists the metadata of all of the different labels and all of the different events that happen in the system, and that's actually in a system called etcd that actually CoreOS built. And so it's actually, remember going back to the Borg slide, it's actually an implementation of the Raft protocol, which is a simplification of Paxos, because Paxos is this crazy gnarly complex beast that people have sort of difficulty sort of wrapping their minds around, and it's essentially a way to just sort of provide persistence with proper locking and consensus and a bunch of different things that Raft provides. In the nodes, or these are formally called minions, you have the kubelet, which is that lightweight daemon that actually runs on all the nodes, and you have Docker engine, then you have your pods, and you have your containers in the pods. So again, any of these things can have any of the arbitrary metadata that you would assign to the labels, and you can do very granular grouping and hierarchical structuring of your services and your applications in Kubernetes. It's an extremely powerful set of abstractions, and unfortunately, in the design, sort of is somewhat confusing to a lot of people if you don't sort of reason through it the right way. If you don't come about kind of understanding the system in the right way, sort of just assume that Kubernetes does this and that, and you don't fully appreciate kind of everything that it's trying to do. The proxies that I was mentioning, they're called services, and again, that's where you do your basic TCP/UDP routing of traffic, and the internet goes and points to that through a firewall. Yep.
They got your hosting OS, they're running Kubernetes on it, and something going to Kubernetes is the Docker engine.
Right.
Which runs the individual containers.
Which runs in the nodes. Yeah.
So this puts, obviously, Kubernetes is a big, massive orchestration and scheduling management layer on top of operating.
Correct. Yep.
A mini
I wouldn't say
Borg.
big, massive, but
It's a mini Borg.
lightweight. I'd say it's pretty lightweight. I mean, you can spin it up. I've got you use Boost Docker.
Yeah.
Yeah.
It's distributed across all of
So it's meant to scale to very large numbers of machines. As of today, it doesn't scale, and there's lots of points of failure. So, for example, let's just get into the kind of the gnarly actuality here. That guy is a huge single point of failure. So, if you don't have something replicating the master and maintaining, sort of failover options, and sort of again, this guy dies, who takes over, and so on. You're dead, right? Similarly, there isn't a fair amount of fault tolerance built into the nodes today. You're not really sharing state across nodes. You really only have failure and sort of process state fault tolerance at the node level. So within the node, if you have pods kind of coming and going, and they're ephemeral, they can spin up and share the state and rebuild the state fairly well, and it's not going to kill you. However, if you have, so if you have a 3-node environment, one node goes down, and you're not load balancing traffic across both of those nodes, you're going to lose data.
So can you define the availability components? Like, I need this application. I only want to have one instance running on a particular node. Can you define that?
Yes.
Okay.
You can do that with labels.
Okay.
Right. So.
Oh, so you'd label your nodes, and then say only one of these per node. You declare that only one of these per node.
Exactly.
Okay, so you said it's got some points of immaturity, and yet there's not major competitors in the space yet, alternatives?
So I would say there really isn't anything out there that you can directly compare to Kubernetes as a single system. Going back to Mesos, you could say that Mesos on top of that, there's a system called Marathon, there's another system called Aurora, which are sort of service orchestrators that have their own sort of DSL for deploying, atomic units and jobs. You could say those things kind of compare, but
you put all those things together.
Yeah, but you don't really have a single system that sort of you all spun up. So Mesos as a scheduler, and then there's frameworks that do service management or service orchestration for long-running tasks. And Aurora is one that Twitter built, and Marathon is one that the folks at Mesos built. But again, this is sort of not a true comparison again, but sort of a lot of companies are building similar architectures with those products.
You have to piece these pieces together to get Kubernetes.
Yeah, I don't want to go too deep on Mesos. It's kind of a big rabbit hole that I probably wouldn't equal that.
I kind of need to understand the big picture.
No, we can connect after for sure. I'm happy to go deeper. So pods, again, are this this fundamental unit of work for deploying containers in Kubernetes. So again, it's a small group of containers and volumes. They're tightly coupled on the same node. They're basically this universal atom of placement. They share the namespace. They share the IP address and local host. So that's really cool for, again, routing traffic and doing the service discovery. A lot of this is pretty early, so there's sort of overlay networks and software-defined network solutions that are being wrapped on top of the sort of port punting, if you will, in Kubernetes, and so a lot of people are trying to figure out how to extend this. But again, you've got your pod here, which again has a volume and your web server and your files, and you're constantly able to communicate and route traffic there. Pod IPs are routable. Obviously, you're not having to do anything like port forwarding or NATing. It's just giving you unique IP for pod and your local host IPs where you actually do the proxying of traffic. So it's actually really elegant that way. This is something that the board paper outlines as a really big learning over a decade of implementing a system like this. They didn't want to have to do assignment, dynamic assignment of ports because it just gets so complex to actually find the services. So you have sort of unique IPs, but then the developer basically has to go and assign the ports, and it gives them a lot more flexibility to do to do the routing, the service discovery. Yeah.
You say can reach each other without nuts, even across nodes, but it's
Not across nodes, only within nodes.
It's like so
Yeah. It's not flannel. It's just this is natively in Kubernetes.
cross nodes.
Yeah. Well, to do across hosts, you can use a lot of different tools. Flannel is one of them.
So nodes here refer to hosts, VMs.
So, really great question. Nodes refer to either virtual machines or physical machines. Exactly. Yeah.
So nodes.
Right. So labels. How do labels work? Again, like I was mentioning before, arbitrary metadata. You have the ability to assign key value pairs to any object in the system. Most of the time, it's pods, and you use that to assign an identity to a pod and actually describe things. They're queryable through selectors, so very similar to SQL select, where you can go in very, very quickly, reason through what's running in the system, and quickly find things based on these labels. It's the only way to actually group, like logically group pods in Kubernetes under replication controllers or services, and again, it gives you an extremely powerful abstraction for a lot of different things. So I think somebody writing a book around what you can do with this, it's pretty powerful. So we have a selector and say, this group of pods is called Nifty, and each one of these has a different phase. You can do really nice things around deployment there. Again, so this could be sort of a different role than the ones on the right. And these guys are all of a sudden app Nifty again, and you're able to do really cool like labeling and selecting and querying things. The control loops is basically how the replication controller works. So you're able to drive current state to desired state. Any gaps between sort of I need 6 pods running and one goes down. This control loop identifies that one died, and it'll spin one back up to get it back to 6. It acts independently. There's no shortcuts there. The current observed state is the truth to that control loop. So you have a nice descriptor here that gives you a really easy way to just basically say I need this number of replicators for this pod template. And again, you've got your selector there to basically again call out the labels that you've assigned to those pods. So just as an example, again, I've walked through this a few times, but you've got 4 nodes. You've got 4 nodes, 4 pods. Let's say one node dies, so node 2 is killed. All of a sudden, your desired state deviates from your current state, and that pod is rescheduled onto node number 3. Right. So this is a really, really powerful way to basically use replication controllers to maintain high availability again within a node, because a lot of the facilities within Kubernetes are built from first principles to just work at a smaller scale. This does not work across nodes today, but that's being solved for very, very quickly. Services, again, as I was mentioning, again, are a way to assign a virtual IP to a group of pods known as a portal. So it basically gives you this access policy to route traffic, and it's basically a way to do your load balancing between groups of pods. So hides the complexity for the developer, and gives you pretty cool primitives. So it's actually called a service portal, where your client would actually come in through that virtual IP and start to route traffic to those pods. Yeah, go ahead.
Do you know how does it work, the load balancing?
Good question.
How does it load balance? Because the traffic goes to proxy, and then how does it decide to forward the request to one pod? And how do you have consistency? I don't know for TCP connections or HTTP connections.
Yeah, and will you be able to plug in other load balancing schemes, et cetera, et cetera?
Yeah, I mean you can.
Can you repeat the question?
Yeah, so the question is sort of actually how is the load balancing implemented, and what can you see there? I mean, it's basic load balancing today. So I think they call it, there's headless load balancing and round robin, I think. So it's pretty basic. You can swap out different load balancers, but you have to again go into Kubernetes and extend this.
So this kube proxy daemon runs on every node?
Yeah.
There's one per node?
Yes.
Okay.
Yeah.
Because do you know if, for example, it is smart enough to, I have application A, which wants to go to application B, it goes through kube proxy. So if there is an application B container running on the same Docker host, is kube proxy smart enough to direct the traffic to the same host, or is it going to do round robin and possibly it will go out? And
it would go out today. So there's a lot of other overlay and extension networking frameworks that are out there that provide that kind of functionality you're saying. So you could actually point it to a specific pod or specific node.
Or wait it.
The
local ones.
Yeah, today everything is really, really basic. So I think
so you could have a lot of east-west traffic here.
Yeah, I mean you'll gradually start to see a lot more granular policies around, more intelligent routing of traffic based on these kinds of constraints. But today it's just these basic primitives. So I'm not sure how we are on time. I kind of wanted to breeze through this.
Keep going. It's all good.
Yeah, I wanted to talk about this final aspect, which is pretty exciting, and then I think we can get into more of the history behind Borg, because this is sort of directly going back to Borg. But a lot of people are curious about, as Kubernetes becomes more stable, how do you actually roll it out to large environments? And how do you sort of have, do you have one Kubernetes cluster that's sort of spanning a data center or multiple data centers? How does this actually work? And there's actually a proposal called Kubernetes, so Kubernetes without the K, and it's basically a federated control plane across multiple Kubernetes clusters. So it's pretty cool. You can have like Kubernetes cluster in your private data center, in your colo. You can have one running in AWS, Google's cloud, or wherever else.
Ooh,
yeah, it's pretty cool. Again, design proposal, absolutely nothing implemented today. It is actually something that's proposed from Google, and we're actively contributing to the design process there. But basically gives you a way to control how you communicate and execute jobs and interact with a large logical grouping of clusters, of Kubernetes clusters that are, again, distinct from one another across network domains, across platforms, across providers, across geographies. And so that's really cool. Now, this is not some random cool idea that came about. Borg is actually implemented in very much the same way. So there's actually a federation control plane that Borg uses to actually allow state to be shared across multiple Borg clusters. And so you don't have this notion of a massive Borg cluster with millions of servers each having this daemon. There's this like global God mechanism executing tasks. There's many smaller clusters of these cells, like remember the notion of the cell in the Borg diagram there. And those are clusters that would be federated and controlled through a higher level control plane. And through this you would have policy and federation, and again your desired state would be maintained at a higher level, at the cluster, at the multi-cluster level or the multi-cloud level. And so this is really, really cool, and I think a preview into what we'll see probably 6-9 months from now, as far as like a built-in component of Kubernetes, an optional component for people who actually have larger deployments. So it's pretty cool. I'll go into some of the use cases here. Why do people need this? Why is this something that's interesting? If you have a whole data center that gets like nuked by an asteroid or like blows up or something, you have resilience to that. You have resilience to availability zone failures, which is a big deal. So if you're running in a public cloud and one of these things goes down, as it happens, and it has, you have resilience to full region, full data center failures. Some people want to have multi-environment deployment of their services and their apps, so they want to have something that sits on the data side that sits in the private data center and sort of the front end stateless services that are very spiky, might sit in a different environment. But again, those are two separate clusters that comprise an application. And so you can have things that are gradually being migrated or that share infrastructure. And so that's actually another big use case. I think this one's a little redundant, but it makes sense at a higher level because you can already run Kubernetes on multiple cloud providers. You just basically take your pod definitions and your containers and deploy them in a separate cluster independently. But what this allows is you to actually migrate your workloads across providers, and so giving you that avoidance of lock-in. Yeah.
Well, the real key, I mean, is when the various cloud providers become a commodity market.
Right.
So it's not, oh, well, next week we're going to run on this other cloud. It's like, this job's going over here right now. Oh, these guys, they've just dropped the rates over here.
Right.
Okay, now I'm gonna launch some more stuff over here.
I mean, I think that, so a lot of the,
and also you could do proximity to where your data is, or proximity where the customer is.
So this is a really big deal. So I was talking with Jordan earlier about what Riot Games is doing, and they built a system very similar to Kubernetes, and the reason they did is because they own all their own data centers, and they need to be able to have very granular policies around where traffic is routed and where services are optimized based on their user geographic location. So they go to public cloud, and there isn't a data center in a specific spot where they have a lot of users and a lot of activity. The latency sensitivities of their service are such that the users will be upset. Like, legends, like if you're not literally within 50 miles of the data center, the latency that you experience will actually be a detriment to the quality of the game and the experience that you're having. And so it's actually a really big deal for them to actually own their own data centers, on top of DDoS attacks that they receive every other day. Cloud bursting is of course a big one. So what are the big issues with this? This is obviously not an easy problem to solve, and Kubernetes in and of itself is solving a lot of core issues that are fairly complex. Location affinity and anti-affinity. So must a given workload span multiple clusters? That's again a question that depends on a lot of the preferences that the company has, or that are specific to the data center environment of the application. Again, you have sort of these policies that might emerge around, is an application coupled to a specific location or region or regions, or is it strictly decoupled or preferentially coupled? So a lot of these things are being considered. Is there political affinity and customer affinity to specific geographies? So that's another.
These pods only run on the other side of the Great Firewall.
Right, and so there's some interesting sort of constraints that you can have around that. Cross-cluster service discovery, I think that's a big one that people are still sort of having to wrestle through, even in the public cloud space, where you have a lot of this stuff already kind of manifest. And I think as Kubernetes becomes more mature, you'll be able to scale within a single data center to a large number of machines. But Kubernetes just gives you this ability to say, I don't need this massive cluster in a single environment. I want to span it across disjointed data centers or availability zones, which is pretty cool. Any questions?
You keep talking about what Kubernetes is going to do, because you said it doesn't exist yet.
It doesn't exist yet. It's a proposal.
Who's going to be writing this?
So this is a proposal from Google, and it's, again...
They're proposing that the free software community write it for them.
No, they're also going to write it. Oh. Yeah. So a lot of the Borg Omega engineers actually at Google have literally been pulled off of writing Borg and Omega code, and they're actually full-time now on open source Kubernetes, which is pretty cool. There's like 40 full-time engineers now at Google.
And there may be engineers that have left Google for whatever reason, but they know that architecture works and would want to contribute to something that they could.
Yeah.
So maybe talking about...
Oh, my computer just died. So.
Okay, good. That's that.
That's that. Oh,
well, but you got through your...
I was pretty much done. Yeah,
you got through your slides. Yeah, I got a charger here.
Do you have a plug-in? So there's actually a couple more that are kind of interesting that maybe.
Plug it right into the part. There's a power strip on the top.
Yeah.
You got a Mac, Carson?
I got a Mac.
Well, here, yeah, actually, I see one right here.
Oh, I see. What was your?
And there's this.
I was saying, with all
Oh,
the engineering.
Oh, right here.
With all the engineering resources from Google,
Here.
these guys must
For
have a pretty fast clip of pull requests on GitHub for the project. Right?
Yeah, they're. Oh, nice. Yeah. Yeah. I mean, there's 960 something pull requests that are outstanding right now on the thing. I think under 160 issues, which is cool. They're closing the issues pretty quickly. Yeah, I mean, there's like full-time Google engineers that are like incented to move the project forward. And obviously, like small scrappy startups like Gizmatic are contributing to it. Red Hat's also a really big contributor.
Like we've had OpenStack presentations here, and OpenStack, it's open development as well as open source.
Yep.
So is Kubernetes an open project? Because there's other projects that Google run that are not open development.
Right. Yeah. Good point.
And since your company's contributing, you'd know.
So yeah, I mean, Google has closed source proprietary products behind their.
No, well, we're talking about Kubernetes specifically.
Okay.
Maybe you want to contrast an Android example of it doesn't develop it and publish it, but community.
Right. There it's.
Yeah, I mean, I think there's some projects that are controlled by
Well,
entities.
put it this way: like you
others
showed
that are
a screenshot, and there's so
democratic.
many pull requests submitted. Who can commit those pull
Anyone.
requests?
You can.
No,
So
I
if
mean, not submit them, but who can actually commit
yeah,
them?
So the commit rights. The commit rights are equally so. Gizmatic has commit rights.
Okay, so there are non-Google folks.
If you're actually contributing valuable things to the project and you're moving it forward,
It's
and
a kind of a merit-based thing.
right. Red Hat has commit rights. Microsoft, I think.
Okay,
Box,
good.
there's a lot
That's
of
great.
companies. I want to say there's 20 or so.
Because Android's not like that.
Yeah.
So, good.
Yeah.
So this is good.
Yeah, they have a pretty solid governance model. One of the things, though, and again, this is sort of it's an open source project, sort of with kind of a benevolent dictator, if you will, right now. Given that it's a young project and it's predominantly built.
Who do you consider the benevolent dictator?
I mean, so Google created the project. They're managing a lot of the evolution.
Yeah, and it was based on their internal work.
But I mean, you could go back to other projects that have been pretty successful in a lot of different models, where there's an open source foundation like Apache Software Foundation driving the governance aspects from an independent board with they have salaried committers and PMCs and so on. And then there's a lot of successful projects, open source projects that didn't have any association with ASF, but they had independent corporations driving them.
Mm-hmm. A bunch of different ways to do it. OpenStack.
Yeah.
But so
OpenStack has its own foundation.
Right.
What we're thinking and considering is that it could make sense for there to be a foundation for Kubernetes, just given that it's extremely fast velocity, and it could be good for the project.
Yeah.
Long term to have sort of a model where a lot of companies are participating in an equal sort of weighted way.
Right. And are there developer summits or how?
Well, the
not all the developers
the
get
meetups
together.
are the extent of it today, I think, and there's.
Because that's the other interesting thing about OpenStack, right? Is they have a 6-month release cycle, and then every 6 months is developer summit, and people are flying from all over the world to wherever it drops.
I'm in Vancouver all next week.
There you go.
OpenStack summit.
Yeah, you know.
So 6,000 people, something coming.
But with all of the change that's happening there, that seems to work for them.
I think it does work, and I would agree with you. I think the foundation model is a solid way to sort of marshal and govern sort of a lot of different.
But Kubernetes doesn't. There's nothing happening like that here yet.
We're pushing for that. So again, when I say we, I mean.
But the first summit hasn't happened yet.
Yeah, and we're actually also working on sort of I'll put it out there, KubeCon. So
there you go. Yeah, whatever it is.
Something for an annual conference of sorts, or maybe even a biannual conference for folks to come together and talk about.
And you could hit it at the user space, developer space, who knows what.
So a lot of these things are really early. They're emerging. It's a really exciting project. I guess I can kind of wrap up since it's getting a little late here. So the future, what does the future look like? That was Kubernetes. That's kind of, again, a design proposal, really cool one. But
yeah, it's
you know, Kubernetes is a very young project. It's less than a year old. You know, not to mistake that momentum as just absolutely enormous. Just to compare it to something that's more sort of palatable, Docker's sort of trajectory or traction within their first 9 months, 10 months was actually less than what you see with Kubernetes today. So less than a year in with 350 committers and 10,000 commits. I mean, Docker had slightly less than that actually within their first year. As of now, there's I think almost 900 committers to Docker. You know, the stars on GitHub isn't really a big one, but there's 20,000 stars on GitHub. There's about 7,500 stars on GitHub for Kubernetes. I think almost 1,700 forks. Yep.
Oh yeah. Is there any place online where we can read more or be involved in discussion about Kubernetes? Because that's directly aligned with a number of things I'm looking at for us.
Everything that I just outlined is not verbatim, but it's actually a lot of the content from the design docs on GitHub.
Right.
So there's links that I can send you literally on GitHub where there's like presentations and proposals and active Google Docs you can go in and chime in on. So yeah, a lot of this. The roadmap itself is right here. So the location on GitHub is /Google Cloud Platform /Kubernetes /blob/master /doc /roadmap.md, and that's basically everything out 6 months. V1, which is a stable release, blessed for production, is going to be hitting in the summer. So roughly June, August timeframe, and that's going to be a really big pivotal point in the history of the project.
But who called the V1 release? Who said, okay, it's...
I mean, this is just something that, this is just something that the
consensus?
core folks are sort of driving around and wanting to say that, you know, we will publicly stand behind 100 nodes and, you know, 50 pods per node, so 5,000 containers, or, you know, even more if you have more than one container in a pod. In production, and that actually some of the folks that we're talking to, there's actually already a fair number of people running Kubernetes in production, not at a huge scale, but with the skill to actually manage all the moving parts and keep up with all the changes, the rapid changes that are happening. So Kubernetes is full of open source.
Is it possible to do a copy of the slide?
Yeah, sure. I'll put them up. I'll put them up online. Sure.
Yeah, if you could maybe at the meetup sites put a comment there. And, yeah.
Kubernetes.io is the official site, so that's maintained by our friends at Google and lots of documentation there. Yep.
I don't know if you know. You have a file section of Meetup. Anybody can post that.
Oh, awesome. Yeah, I'll just post them. There.
Oh, you can actually post the files on too.
Put the whole file there.
Sure.
Yeah.
Cool. Very, very active Freenode IRC group at hashtag Google/containers. This is us. Usually 10 or so folks there. Kismatic is here, and Kubernetes. So again, I work for Kismatic. We're a Kubernetes company. We're the first and only open source sort of software company focused on Kubernetes. We don't have anything proprietary. Everything we're doing is all going to be pushed back into open source. The one sort of agenda that we have is to make sure that people are successful with Kubernetes, that they run their services on it and actually get into production. That's what we really want to see. We want to see success stories that encourage other people to be less sort of hesitant and concerned about the stability, because it is beta software. It's very early.
Yeah.
And it's very fast moving. So we just want to see people be successful. So our CEO is the second biggest contributor to Kubernetes. And we have a lot of contacts with a bunch of folks that are playing with it. So that's the pitch for Matic.
So how much Google is helping this in this endeavor?
In our work, yeah, we're pretty. You know, we have weekly standing sprints with them on kind of the status of the project, and they were also a pretty big contributor to the web UI.
And right, your CEO with Patrick, right? And he's speaking at a Google event up north,
Yeah, so
right? Which is why he couldn't even come down here.
Right. Yeah. So the conflict with Patrick was he's actually at an event at Galvanize, which is an accelerator in San Francisco, and there's a panel with Mesosphere, CoreOS, and Patrick,
oh, really?
And some other folks.
Oh, you got to post up the link. Are they streaming that too?
I don't think they're streaming it, but I would be surprised if people
if it's recorded. Yeah, because that's going to be a nice bloodbath.
Yeah, I don't know if it's a bloodbath.
Oh,
I mean,
come
we're
on,
friends.
we
So
want
Patrick's still an advisor to Mesosphere, and we're still friends with all those guys.
But yeah, there should be some good discussion then.
Yeah, so that's it. I think for all of you guys, just I'd encourage you to go to Kubernetes.io, play with it.
You should talk for a minute about Kubernetes SoCal meetup and what you want to do there, because you've got a captive audience here and potentially people that are going to be using it in the next couple of weeks. And you're going to need speakers. But I think getting Patrick down here for your next
come
meetup.
down for sure at the next meetup. I think maybe monthly or every other month we'll have a meetup. And the goal is to just really build it. I think right now we have 50 members in the group. I guess about a month old.
It's going to change. Yeah, you don't really know. This is all a moving target.
Brand new. I haven't promoted it. I've tweeted about it a couple times, but it's not at all something that's really been publicized. So I'd imagine by the end of the year, there's probably going to be hundreds of folks in the Bay Area. There's already about 500 people in the Bay Area Kubernetes meetup. And yeah, the goal is to just, if you're using Kubernetes, if you're playing with it, if you're actually intending to do some interesting, serious things, and you want to talk about some of your experiments or some of your learnings, get in touch with us. Just shoot us a note at the meetup.com/Kubernetes/SoCal, I think it is. But if you just Google Southern California Kubernetes, it'll come up. And yeah, basically it. Thanks guys for having me.
And hey, congratulations. So yeah, thank you, Joseph, for making this whole thing happen this month. So yeah, if you haven't joined the Kubernetes meetup space, it is linked from the UUASC meetup space. So I assume he's just going to spawn that, and who knows, maybe he'll have meetups here.
Yeah.
And you're going to want to. You've got a SoCal focus.
Right.
So you'll probably do stuff in Irvine and also down in OC, and who knows, maybe you can make it up to the North Valley, Pasadena's.
And if we have something really cool going down in San Diego, maybe we'll do one down there.
Well, the other one is you can always stream them too.
Right.
So then we can lurk from abroad.
But I just want to say thank you to Jordan and thank you to Q for hosting us. Great space. And,
we're gonna head over to Islands for maybe some more food or drink or whatever, but definitely for some continued conversation. So you're welcome to join us over there as soon as they break my stuff down. And if you don't want to go there, that's fine, but you can't stay here. So hit the road. Oh, good. Thank you.
I didn't realize I know.
So, anyway, not so
No, don't feel pressure. No, this is good. Calling card.
So are you over here looking about every month?
Yeah, the first Thursday of the month. Usually here. Usually here.
Well,
And
as
it's
you can
also
tell,
online.
I've not been paying much attention on the mail.
Hold on. Before you confess to all this stuff, let me stop recording.